Hello children, welcome back to my channel. I am now doing 8th class maths, and in 8th class maths we have got squares, roots and cube roots. In this chapter I am dealing with. In this, earlier I have done about certain patterns, try this and do these sums. Now I am going to do exercise 6.1. So the first problem of 6.1 is, what will be the units digit of the square of the following numbers? Certain numbers are given to you. In their units digit, what are you going to get? Already this kind of example sum I have done. So in a tabular form, I am going to do it. So first let me write serial number and what is the number given to you and what is its units digit. In the given number, what is the units digit? And the next one, square of units digit. In the units digit, if you find square, what are you going to get? And what is the question? Units digit of the square. Units digit of the square. So as I am doing the sum, you will be understanding how it has to be done. The first bit is, you have got the problems. First one, you have got 39. So in this, units digit number is 9. That I am writing here. Next, square of this digit, 9 square is 81. 9 square is 81. Now, units digit of the square. That means if you find out the square of 39, square of units digit of the square of the number. Okay, square of the given number. I'll write that. Square of the given number. The given number is 39. So 39 units digit is 9. 9 square is 81. So what is the units digit here? 1. So 1 is the answer for this problem, children. Now let us see the second one. What is the second one? 297. So what is its units place? 7. So what is this 7 square? 49. So what is the units place of this? 9. So 9 is the answer for this problem. And third bit, 5, 1, 2, 5. So units digit is 5. So this 5 square, how much are you getting? 5 square, 25. So what is the units digit here? 5. So 5 is the answer for this problem. Now fourth bit. Fourth bit is 7236. 7236. 7236 is the given number. In its units place is 6. So let me write that as 6. And 6 square, you are getting 36. So what is the units digit here? 6. This is the answer, children. Next, fifth bit. 8, 7, 4, 2. 8742. So units digit is 2. So I am writing that 2 here. So 2 square. How much am I getting? 4. So it has got only one digit, units digit. So 4 is the answer. Instead of doing separately this problem, children, I have done it in the form of a table. I think this will give you a clear-cut understanding. Let me divide them also. This is, in this way, if I divide, you will understand more clearly. The whole problem, I made it in the form of a table. I hope I am clear, children. First one is serial number. Second one is given number. Next, units digit of the given number and square of the units digit and units digit. This is the one, units digit of the square of the given number. Given number is 39. It's a square, 81, 1. So like that for every problem I have done. I hope It will give you a clear explanation for this problem. Children, please note it down. Now, the second problem, children. Which of the following numbers are perfect squares? They are asking, you have to find out whether they are perfect squares or not. Perfect squares means what? You should get the given number as square of some number. That means you should have only one pair of the numbers of the same type to multiply. Then if you get the same answer, you will be getting that is the perfect square. So if you take 121, we can write that 121 is 11 into 11. So two same numbers you are multiplying. So we will say that it is a perfect square. Which of the following are perfect squares? They have asked. First one is the perfect square. Second bit, 136. So 136, this means table you know very easily you have done. But this number, let us do prime factorization. 136. 2 6 are 2 8 are. 2 3 are 2 4 are. 2 1 are 2 7 are. You can check once again. 2 6 are 12, 2 8 are 16, 2 3 are 6, 2 4 are 8, 2 1 are 2, 2 7 are 14. 17 itself is a prime number. So we will be saying that this is nothing but 2 into 2 into 2 into 17. So in this, these two can be made as one group, but these are separately you have got. There are no pairs for it. Therefore, we will say that 136 is not a perfect number. By finding prime factorizations only, you can understand. Now, third bit is 256. So, let us take 256. 2 ones are, 2 twos are, 2 eights are. 2 6 are, 2 4s are. 2 3s are, 2 twos are. 2 ones are, 2 6 are. 2 8s are, 2 4s are, 2 twos are. So, how many twos? 1, 2, 3, 4, 5, 6, 7, 8 twos we have got. 1, 2, 3, 4, 5, 6, 7, 8 twos. Can we make them as a group? Let us see. These two can be made as one group. This can be one group. This can be one group. This can be one group. Do you have any number extra? No. So you can convert 256 as the factors of same numbers. No number is extra. Here you see, you can make this as a group, but you cannot make this as a group. So it is not a perfect square. But here when you see the prime factorization, two groups are possible. Therefore, you will be saying that 256 is a perfect square. I hope I am clear, children. To find whether the given number is a perfect square or not, go for prime factorization. After getting all the prime factors, underline 2 values like this. If you are able to get like this pairs without getting anything extra, then that number is a perfect square. Here you have got extra, so it is not a perfect square. So this is third bit and fourth bit. Fourth bit, I'll do it here. 321. 321. So, with which table it goes? 3 means yes, 321 can be divided by 3. 3 ones are 3, 2 you cannot, so you have to keep 0, 7s are. So, with which table again it goes? You cannot find any other table. 107 means 9, 9 you cannot, 11 you cannot, 7 you cannot, 7 1 is 7, 37 you will be getting. So you are going to get it as 3 into 107. So it is not a perfect square. Next, fifth bit, 600. So take 600, 2 3s are 0 0, 2 1s are 2 5s are 0, 3 5s are 0, 2 2s are 2 5s are 5 5s are. So 600 can be written as 2 into 2 into 3 into 2 into 5 into 5. So here these two can be made as one group, these two can be made as one group. But what about these two? There are no pairs for it. So you cannot write it as a perfect square. Therefore, you will say that 600 is not a perfect square. So I hope I am clear, children. To get a perfect square, you should have pairs like this. Please note it down. Now the next problem is the following numbers are not perfect squares. So you need to find what is the reason. Why are they? The problem itself, in the problem itself, it is given that the numbers are not perfect squares. Why is it they are asking? In the first class, I think I told that in units place which numbers are there, then they are not perfect squares. I said 2, 3, 7, 8. If these numbers are in units place, then the numbers are not perfect squares. This I have taught to children. Numbers are, I'll write numbers are not perfect squares. This is a kind of recollection I am saying you children. When I was dealing with the initial introduction class, I said, in the units place, if you have 2, 3, 7, 8, then the number is not a perfect square. So that is what he is asking. The following numbers are not perfect squares. Give the reason. What is that here? First one, units digit is 7. So what is the reason? Units digit is 7. So it is not a perfect square. It is not a perfect square. This is the reason that I am saying, children. This is the number given, this is serial number. So next one, 2. See, there 2 is there. So the same reason, units digit is 2. So it is not a perfect square. Next, units digit is 3. You have 3 there. So units digit is 3. So it is not a perfect square. This problem is only to make you well versed with this formula. Here 0. There is no 0 children there. Then why is he saying that it is not a perfect square? See, if you have a 0 here, you need another 0 to pair the zeros. So there is only one 0. So units, it has, you will say that it has only 1 0. If it has got 2 zeros, we can think about, but it has only 1 0. Therefore, in it has only 1 0. So it is not a perfect square. It is not it has only 1 0 means I am talking about units. Don't think about this is second 0 is there. No, don't think. You have to, it has only 1 0. It needs consecutive zeros, so 2 zeros. So 1 0 it has got, so I cannot write in units place because units place will be having only one digit. So I cannot give an explanation here. It should be two digits in units place. Is a very wrong statement. So what am I saying is, it means what? In the place of 5, there is no 0. So that is the meaning of it. Here also, if you have 0, we can think about it, but there is no 0 over there. Units place has got only 1 0, so we cannot, it has only 1 0, so it is not a perfect square. So here it has got units digit is 8. So here you have 8. So it is not a perfect square. See children, here even if you have a 0, of course with this you will not get it. But the thing what I want to explain to you is, this problem is just by looking at the sum you should say the answer. It is not, see, in the earlier problem we have done prime factorization and we have seen whether it is a perfect square or not. Here we are not going to do it like that. Just he has given the answer that it is not a perfect square. Then where is the question of finding perfect squares and seeing whether it is a perfect square or not? So that will not arise. So what is the problem asks us to do? You should, by seeing the number, you should identify whether it is a perfect square or not. So we have got a formula for it. That is, if units place has got 2, 3, 7, 8, you can directly say it is not a perfect square. But they have given 0. Actually, when if you go through the earlier topic which I have taught, 0, if it is there, in some cases you can see that it is a perfect square. But if you observe carefully, if 3 digits are there, like 900, 9 means you can write 3 into 3 instead of 2 zeros, 1 0, 30 into 30. So like that you can do only when you have 2 zeros. Lastly, that is the tens place and units place. Both the places, if there are zeros, we can check whether the number is a perfect square or not by seeing the other values. But here, you have got only in units place 0. Tens place there is no 0. So directly by observing the number, you can say that it is not a perfect square. I hope I am clear, children. Understand this, and please note it down. Now, let us see the next problem, children. Fourth one. Find whether the square of the following numbers are even or odd. Means when you find this square, the given numbers are this. When you find the square of this number, is that number odd or even? We know generally any number can be considered as even or odd by saying its units place. So in units place, if you have even digit, that means if you have 2 or multiples of 2 including 0, we will say that it is even. Other numbers are odd. So this primary basic knowledge every one of us are having. So basing on that, we are only considering the units digit of the given number and find out what is its square. In that square units digit, is it an odd or even? Very easily you can determine. So this also I am going to do in the form of a table, children. The first one, 431, its units digit of the number is 1. Square of that number, 1 square is 1. 1 means it is an odd number. Second one, units digit is 6. Square of 6 is 36. 36 it is 6. 6 is an even number. So it is an even number. And 4, units digit is 4. 4 square is 16. So units digit is 6. So this is also an even number. And the fifth one, you have 9. 9 means 9 square is 81. Units digit is 1. So we will say that it is an odd number. And here you have 8. Units digit is 8. That means 8 square will give you 64. 4 is an even number. So we will be saying that this is even. So easily you can solve this problem, children, without finding squares of this number. You need not multiply these big numbers again and again. Just observe the units digit. You can get the answer, children. Please note it down. Now the question is, fifth one, sorry, how many numbers lie between squares of the following numbers? That means he is asking 25 and 26 means numbers between. What does this implies? Numbers between 25 square and 26 square. So children, this is nothing but we have done a formula. I have taught you when I was doing the first or second video. If you observe, you will be getting the number of numbers between these two is nothing but 2 into base of first number. This is what the formula we have taken. 2 into base of first number. That means here base of, see, this is base, this is power. 25 is the base, 2 is the power. Base is 25. So 2 into 25, that is 50 is the answer for this bit. And the second one, what does this mean? They are asking to find out numbers between 56 square and 57 square. So this is also nothing but 2 into base of the first number, that is 2 into base of the first number 56. 2 6 are 12, 2 5 are 10, 1 11. 112 is the answer for this number. And this is also numbers between 107 square and 108 square. This is what he is asking. This is nothing but 2 into base of the first number. So 2 into base of the first number is 107. So 2 7 the 14, 2 1 the 2. 214 numbers will be there in this problem, children. Please note it down. This is fifth one. Now, sixth problem, children. Without adding, find the sum of the following. This also I have done in the example. Do this, I think. Do this, try this. In that you can observe, children. If you have odd numbers sum, this is nothing but what you need to find out. Find out how many number of terms are given to you. That square 1, 2, 3, 4, 5. That means it is actually n is equal to 5 here. This problem implies n number of numbers 1, 2, 3, 4, 5 are there. Therefore, sum is equal to n square. This is the formula, that is 5 square. 25 is the answer. So if you add, you will get 25. You can check, children. 7 plus 3, 10. 9 plus 1, 10 plus 10, 20, 25. So this is the easiest way. What does this problem says? N how much you see? 1, 2, 3, 4, 5, 6, 7, 8, 9. N is equal to 9. Therefore, what is the sum? Sum is nothing but n square. That is 9 square. That means 81 is the answer here. Now for this problem, what is n? How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. N is 13. So, what is sum? Sum is n square, that is 13 square. 13 square is 169. This is the answer for this problem, children. Please note it down. This property I have already taught you, children, in the earlier case. You can go through the previous videos. With this, I am going to conclude my topic today. Next part, I will do it in the next class.